Alrighty, so I didn't expect to be gone, so we were going to learn so many fun things with me in the room. Now you're going to learn really fun things without me in the room. You're welcome. Basically, kind of goes like this. Where's paper? When you go to solve in this chapter 3, because we aren't out of the chapter, we just had a quiz on the first sections. When you go to solve, always in math, our goal is ultimately to solve a variety of questions or styles of equation. So the two things that we've been looking at are exponentials and log. So the first thing you do is you decide if it's exponential or log. And you do that with your eyeballs because it's exponential if x is in the power, and it's log if it says log, or potentially ln. Super tricky. Then if it's exponential, you're going to decide, can it be written as the same base or not the same base? And then there's going to be a solving method for each of those situations. And then with logs, you're going to use your eyeballs to decide, are there logs or ln's on one side of the equation or on both sides? So there's 4 cases that we're going to look at quickly, basically through example. And that's how it plays out, is it's going to be one of these 4 scenarios. Do you know how to do these? Do you know how to do this? You know, identifying what it is easy. You're using your eyes. And then once you've identified which of the 4 it is, you have to know your plan of attack. So let's go back up to the top. Like I said, exponential equations have x in the power. And basically what you're going to do is you're going to rewrite the equation with both sides having the same base to something equals the base to something else. Smiley face, sad face, whatever it is, just like the last quiz, like you can't obsess about what it is because it doesn't matter. You're just getting the bases the same. And if the bases are the same, the only way those 2 statements can be the same is if the power equation is the same. So you're just going to go ahead and cancel the base. So for example, if you have 2 to the x equals 2 to the third, the only way those are going to be equal is if x is 3. So you'll just solve whatever remains in that, the equation that was in the powers. So let's just try this. So here I see this and I go, okay, this is 2. 2 to the x minus 1 power. 1/4 can be rewritten as 2 to the negative 2 power. I haven't added anything or subtracted anything from the problem. I just rewrote that because 2 to the negative 2 goes 1 over 2 squared, which becomes my 1/4, which hopefully by now you just know and we're not trying to learn. But that negative 2 is now up in the power with the stuff that was already there. So now I'm going to cancel the bases, and what I have left to solve is the things that were up in the equation, up in the power. That's my power equation, and I'm going to go ahead and solve that. So I guess if you wanted to say up here, you could say solve power equation, if that helps you kind of keep track of specifically what am I solving. So now you go back to Algebra 1, you're going to distribute your negative 2, you're going to move the negative 6 over by adding it. You're going to move the 1 over by adding it, and you're going to divide, and you're going to get negative 1/7, which feels like the wrong answer, but it's not. And if you had a calculator, you'd be able to plug it in and check. So you're good to go there. Same situation here. I can rewrite both as a power of 5. So if you're like, yeah, but I'm bad at powers. You can't be bad at powers. We're kind of at a place in your math life where you have to be good at powers. So all I did was rewrite 25 as 5 squared and 625 as 5 to the 4th power. And now I've accomplished my goal of getting the same base, so I can cancel the base, and then I'm left solving what was up in the power as my equation. So this becomes an 8x. Distributing, I get 4x minus 12. And I'm going through this part fast because to me this is Algebra 1. I'm moving that 4x over to the left, and I'm ending up with a negative 3. And if it's worth $1 million, you can go ahead and plug it into the original problem and convince yourself that it's correct. Since there's no prize for being done first, you might as well take some time to do that. Okay, so this one's kind of tricky, but once you see it, you should use that trick again. If you are asked to solve this using the same base, you don't have a choice but to figure out how to rewrite this as a base 7 problem. So think about it. Anything to the 0 power is 1. So I'm rewriting that side as 7 to the 0. Then I can cancel my 7s, and my 2x plus 3 equals 0 becomes my algebra 1 equation, and I end up with -3/2 as my solution. Isn't that slick? I think it is. It's pretty fun. You're welcome for teaching you that fun thing. Ooh, this one looks scary. Okay, not really. Obviously, the base that I'm going to use is E. The left side has already got a base of E, and so just think, you by now have to know that that is E to the -5th on the right. I'm canceling out my E's, and I'm solving what's left in the power equation, and so this becomes pretty easy peasy. Get it? Easy? Just kidding. Okay, so that is kind of case 1. So all of those are exponential, and finding that they're exponential is an eyeball activity. You go, oh, look, x is in the exponent, therefore it's exponential. Get it? Very straightforward. So these next problems, x is still in the power. We're still looking at the exponentials. We just talked about here where you can write them as the same base. Now we're going to talk about what if you can't, and this is going to be a calculator activity. You'll notice I didn't need a calculator for those last ones. So here what you're going to have to do is you're going to isolate, we call it in math, we say to isolate, but that just means get it alone, the exponential part. So get the exponential term alone. And then after you've done that, you're going to use the verb that we did before, which was convert, or you could rewrite, those are the same thing. Instead of as a log or ln, instead of as an exponential, you're going to rewrite it as a log or an ln. So that goes back to just remembering that, hey, if you have a base to a power equaling an answer, that can be written as log of that base with that answer sitting there, and the power goes over on the right. Once you do that, you're going to be able to solve that equation, and you're likely going to need your calculator because they're not going to be problems you can necessarily solve in your head. So in this first case, equation, this is the part that I need to isolate or get alone. So I'm just going to take 8 away from both sides and have my 6 to the 2x minus 4 part alone. And then when I take that 8 away, my 24 becomes a 16. Okay, that is step 1. Now I need to rewrite it. So I write it as the log of my base with the 16 here, and the power always goes alone. The power always stands alone. So it goes on that other side. I'm just using this and the ability to go back and forth between them. All right, so now I use my calculator. You can do your math log base to get whatever this log base 6 of 16, because it's asking 6 to what power 16. I don't know that, but my calculator does. So I'm getting 1.547 for that off my calculator. Now I'm going to just do more math, and unfortunately I don't have a ton of space. So I'm going to add that 4 over to the other side. Oh, sorry, I missed a value there. So I'm going to have 5.547, and then I'll be dividing that by 2. So in the end, I'm getting that x is about, because I rounded off, 2.774. Okay, so let's see if I can maybe be a little more efficient with my space. Here, my exponential part is this guy. The 2 is a part of the actual problem, not like number 2, as in question 2. So I need to get rid of the 7, so I'm going to go ahead and do that by adding it to the other side. So I have 2e to the 3x equals 18. I'm trying to get the exponential part alone, which is my e to the 3x. So I divide by 2 and get this. So now I've isolated the exponential part. I only have the base to the power, so I rewrite it. Since it's log base e, I write ln, 9, and then the power stands alone on the other side. Then I just go to my calculator and I find out what ln 9 is, and then divide it by 3. So here I get that x is about 0.732. I did these earlier on my calculator, so I'm hoping those numbers are accurate. All right, so here when I'm looking, I've got this part, that's my exponential, so I need to move that 4 over by addition. So I have my 1/3 to the 2x plus 5 power equals 10. You're not going to do anything with the third because that's inside the power part. So what I need to do now is rewrite this as an exponential. It's going to be a log. The base is the thing that was raised to the power, 10, and then the power stands alone. The power always goes over there alone. So again, I get out my calculator, I do math, I scroll all the way down until it says log base. If you don't have that feature, you're going to use the change of base and you're going to have to do log 10, shut that down, divided by log 1/3. And you should get the same decimal answer that I'm talking about using the log base function for. If you don't know if your calculator has a log base function, ask your friends. They probably can help you find it if your calculator is new enough to have it. So that becomes my negative 2.096. I take my 5 away, and so I end up with negative 7.096, and I divide by 2 for an answer of about negative 3.548. And my equal sign looks weird, like squiggly, because these are not exact values, just because I'm cutting them off. So that is my exponential part in this last example. I'm going to add 4 to the other side, but I still don't have the exponential part alone yet. And so after I add that, I get a 15 over there. Then I'm going to go back and divide by that 2 that's out front. Don't be afraid of a decimal or a fraction here and there because we're actually in honors math. So I believe that you are capable of managing those, particularly with your calculator. So I'm going to rewrite this as a log, and since it's log base e, I'll write ln. If you get confused, remember that your power always stands alone over there, so the 7.5 goes right here, and there's not a specific base written because it says ln. I do this on my calculator, and I get like 2.015. I add 5, and I divide by 2. So I'm getting that x is about 3.507. And again, this is solving, my friends. So if you are in doubt about your answer, go back to the original problem and plug it in. Okay, so this next one looks very complicated. I'll call it a thinker. But once you see one like that, then you would always use this same approach. And you're going to know a problem like this because it's going to be e to a power. The ACT loves these, by the way. They like to toss these in towards the end to see who's a true smarty pants, so you should be one. Notice that the power of this is double the middle. So 2x with an e to the x in the middle. Anytime the first one is double the middle, there's the potential for factoring. So you're going to rewrite it in a way that's more familiar to your brain and make it easier. You can use y, x, p, q, whatever your favorite letter is, but I'm just letting y be my substitute, and you substitute this middle plane e to the x. So then I can rewrite this as y squared minus y plus 2 equals 0. And if you don't get y, no pun intended, if you don't understand, this y equaling ex means I put a y in the middle where the ex was. And if you take x and you square it, like in this first term, it just becomes e to the 2x, because in that setup, we know that you just multiply the powers. So that e to the 2x is really my ex squared, therefore y squared. So once I know how to set that up, then I can go ahead and factor it like I'm in Algebra 1. I need 2 in a way that adds up to 1. I need the 1 to be negative, but the zeros, the solutions would be these. But that is currently just y equals. But we substituted in y so that our brains would recognize how to factor easier. But that's really our e to the x values because that's what y was in place of. So I'm going to rewrite these as ln so I can do them on my calculator. So this would be ln of negative 1 equals the power, ln of 2 equals the power. But this one, you can't take the natural log or the regular log of a negative number, so that does not contribute any solutions. The ln2 does. And when I do that on my calculator, I get approximately 0.693. So that's the only valid answer. And on the ACT, they will probably just leave the answer as ln2 because they say that you don't need a calculator to take the test, but you really do. Okay, so now we have looked at the first two types, all of the exponential options. Either you can have the same base, so you write them with the same base and cancel, or you cannot get the same base and you basically isolate the exponential part, rewrite it, and solve. Okay, let's keep making our merry way through. We're going to talk about these. And actually, these two end up to be a little bit easier, I believe. Definitely the last one tends to be easier. So the entire point of learning how to condense, expand, evaluate, convert the logs was so that you would have the skills you need to solve log equations. We have never solved log equations. By the way, FYI, these guys back here with x in the power, those are the ones that we were solving by saying, well, I know that the function's doing this and I know the other value's this, and let's see where they collide. That is not going to be a thing anymore necessarily, because now we have the power, no pun intended, to solve when x is in the power. So we'll be able to use those skills to find the power without having to graph. You're welcome. All right, so let's go ahead and take a look at this first case within the log equations. You'll know it's a log equation because it says so. Oh, one thing you got to pay attention to. I know that nobody in the history of ever actually checks their answers, but you really should with these, because very often you will get values that you can't actually use because you cannot take the log or natural log of a negative, like the problem right here. But in these problems, you're going to get an x value. Just because the x value is negative doesn't mean it won't work. And just because the x value is positive doesn't mean it will. So you actually have to go back. It's not really a math thing. You just use your eyeballs and you look at the original problem quick and see if any of the values that you got force you to take the log of a negative. I'll show you. But first, what do we do? Well, the first thing we're going to do when we see logs or ln's and we only have them on one side of the equation, if we need to, and we don't always need to, we condense those logs based on the properties that we learned. So condense your logs and ln's and maybe make yourself a note if needed, because you might not need to do that. Once you've done that, you're going to rewrite or convert, whichever verb is your favorite today, to exponential. Now, that is the exact opposite of what I set up above, but that's been what I've been saying from the start. These are math opposites. If you got a square, you square root it. If you got a square root, you square it. If you've got an exponential, you log it. If you've got a log, you make it an exponential. They're math opposites. So you're going to rewrite it, and then once you rewrite it, you'll be able to solve. But in this case, make sure that you do actually check that the number you're getting isn't forcing you to take the log of a negative. All right, so let's go for it here. The fun just never ends. So these need to be condensed, and like I'm looking at the problem and I'm saying, oh, I have a log here and here, but they're both on the same side of the equal sign and there's no logs on the right. So that's why this is the kind that has logs on one side. Okay, so I need to condense these. I learned before that I condense them with division. Okay, and so then I'm going to rewrite this in exponential form. Since it's ln, I'm going to have like an invisible e here, and then I'm doing this whole deal, the log rule. So I'm going to write e to the 0 equals x over 3. Well, that means 1 equals x over 3. So that means that x has a value of 3. I go back up here and I see that I would be taking the natural log of 3. All is good in the hood. I move on. Here I go, hey, look, there's only logs on one side of the equal sign. I know how to do that. I condense. And again, those are separated by subtraction, so I put one over the other. This one's log, and it doesn't have a base written, so I use my smarty pants to know that that's the common base of 10. Then I do the log roll. 10 to the first equals x over x minus 3. Okay. Except, yeah, I'm looking at the filled in notes, and for some reason that I do not yet understand. Oh, great. This is supposed to be plus. I'm going to change that. So I'm going to have to put that into, I guess I can solve it both ways. So let's just go ahead and do what I was doing, and then I'll solve it the other way because I want to show you what happens if it's adding. Okay, so struggle bus. X over x minus 3 equals 1. I'd have 10 to the first equals x over x minus 3. If that's confusing, just think of it like cross multiplying. So I get x equals 10 times x minus 3. So I'd have x equals 10x minus 30, which would be negative 9x equals negative 30. And so I'd end up with x equals positive 30 over 9, which would reduce to 10 thirds. Okay, I look up here though, and 10 thirds minus 3, even though 10 thirds isn't negative, 10 thirds minus 3 is. So that would force me to take the log of a negative, and so that actually doesn't work, and it's the only option I got. So that means this particular problem, as it was written, has no solution. I do want to look at it without the typo, which means what would I do if this problem had a plus sign instead? Then I'd be solving log, and I'd condense them through multiplication. And this is the one that's on the filled in notes. So this is going to be x squared minus 3x equals 1. It's still base 10, or common base. So I have 10 equals x squared minus 3x. In order to solve a quadratic, I need it equal to 0. So I move that 10 over. Then I factor 5 times 2, negative and positive would be the factors for that problem, meaning that x would have to equal negative 2 or 5. Okay, so if I go back up to the top, I can't use a negative 2 here or here, double sad face, because they both would force me to take the log of a negative. So this is not a viable answer, but the log of 5 and the log of 5 minus 3, but 5 minus 3 is 2, not a negative number. So this is the only viable option. So as written with the negative sign, there was no solution. But if it had a positive, as it should, to match the notes, then it would only come out to have this one solution. Alrighty, so let's tackle this next one. Again, try it and then just see. I'm going to multiply the parts because they were separated by addition. So we learned that in condensing. I'm going to rewrite this. So this is going to turn into this. 3 squared equals x times x minus 8. But that's going to be 9 equals x squared minus 8x. Again, it's a quadratic, so I need to bring the 9 over in order to solve it, hopefully by factoring. 9 in a way that subtracts to be 8, and I need the 8 to be negative. So my x can be a negative 1 or it can be a positive 9. Checking up here, it can't be a negative 1 because in both of these cases, negative 1 would force me to take the log of a negative. And then how about 9? 9 works here, and 9 minus 8 is a positive number. So that's going to be okay-dokay. And then this last one looks a little bit different. I don't really need to condense it, but I'm going to need to get rid of the 2. So I do that first. Now I have log base 5 of 3x equals 2. And I go ahead and do that log roll to rewrite it exponentially. So I have 25 equals 3x. dividing by 3, I get x equals 25 thirds. And that's an exact value, so I just leave it. I don't really rewrite it as a decimal. I just let it be. Okay, and then I look up here, and since it's 3 times x, 3 times 25 thirds would be a positive number. And so I don't have to worry about, like that works in the equation. I don't have to eliminate that option. All right, last case is what if you have them on both sides? And this looks really complicated, but it actually usually turns out to be the easiest of all of the kinds to solve. You're like, okay, I can see with my eyeballs that there are logs on both sides. So what I'm going to do is go ahead and condense again on each side. So I'll have one log on the left side and one log on the right side. And since I have them on both sides, at that point, I can cancel out the log or the ln. And then you just solve whatever problem remains. But here again, you want to check because you're starting with logs. So there's a possibility that what you get as an answer will force you to take the log of a negative. So here, I can see with my eyeballs that there's an ln on the left side of the equation as well as on the right. The left side does not need condensing. It's already just a single log. But on the right, these have to be put together. They're separated by adding, so I put them together by 4x, like multiplication. So now the only way these will be equal, the natural log of x plus 3 and the natural log of 4x, is if those two remaining pieces are equal. So now I'm pretty quickly into an algebra 1 problem. I take that x over to the other side and I get a 1. I check here, natural log of a positive 1. 1 plus 3 is 4. I don't have any negatives. I'm good to go. This one looks complicated, but it's not. I don't have to do anything. I only have one log on the left and one on the right, and they'll always be the same base. So the only way the logs will be equal is if these two expressions are equal. So then I'm going to take away my 3x to the left side, and I'm going to add my 2 to the right side, and I'm going to divide by that negative 2 and get a negative 3. But then I'm going to go up here and say, okay, but if I plug in a negative 3, this whole thing becomes a negative number, because it would be negative 9 plus 4. So I'd be looking at taking the log of negative 5, which you can't do. And same thing here. I'd be putting that in and taking the log of a negative 5. So even though the numbers themselves are equal, it's not mathematically possible. And so in the end, I have no solution. Now on the test or quiz, you have to show your work to support the fact that you didn't get an answer. You can't just write no solution. You have to show that, hey, I got a negative 3. It's not wrong that it's negative, but when I plug it in here, it makes me take the log of a negative, which I can't do. And in this last example, I know you're grateful that it's the last one, these have to go together by multiplication because they were separated by, by addition. And then over here, I need the ln without a 2 in front, so think about where else it can go. ln x squared. So I'm going to cancel these ln's, but now I need to FOIL this thing out. So I'll have 2x squared minus 7x plus 6, and I'm not teaching you how to FOIL. I need it equal to 0, so I move my x squared over by subtraction. And then I see if I can factor it. I need 3 in a way that adds up to 7. So, 6 in a way that adds up to 7. So I use 6 and 1. To make a negative 7, I'll use both negatives. To get it to equal 0, x would have a value of 1, or it could have a value of 6. But if you plug a 1 in here, 1 minus 2 would have you taking the natural log of a negative 1, which does not work. So this, even though it's not a negative number, still does not work in the original problem because I end up taking the log of a negative number. If I check my 6, 6 minus 2 is 4, which is positive. Here, if I plug in a 6, I'll have 12 minus 3, which is 9, but positive. And here, if I put in my 6, it's positive. So the only one of those two answers that's viable is going to be that 6. So what you need to do when you look at your solving problems is just decide which of these 4 situations you're in, and then how do you go about solving from there. So hopefully that helps you out. Use the notes, use the examples, use the answer key. It's Miss Arnold's key, so I can't speak to it. Oh wait, that might not be true. I think I put my own on there. But either way, use the answer key, use your big brain, use your neighbor's big brain, figure it out, because we are going to move on and do something different tomorrow. So I'm not going to be reteaching this. I'm just going to have you be big brain smart people and know it. I will see you soon. Bye.